Welcome to Nardar Academy. In this video, we are going to discuss about beta and gamma functions in integral calculus. Okay, so what is meant by beta function and gamma function? What are their properties? And we are going to do few problems based on beta and gamma functions. See, the first Eulerian integral is called beta function and the second Eulerian integral is called gamma function. The definition is beta of mn equal to integral 0 to 1 x power m minus 1 into 1 minus x power n minus 1 into dx. Okay, so here mn means the power should be what? M minus 1 and n minus 1, and the gamma function is defined as gamma of n is equal to integral 0 to infinity e power minus x into x power n minus 1 into dx. Here m and n can be any positive numbers. They need not be integers, they can be any positive numbers. So let's see some properties of these two functions. The first one is beta function is symmetric about m and n, that is beta of mn is equal to beta of nm. Beta function is symmetric with respect to m and n, index m and n. Next one is gamma of n. No, by simplification we can arrive gamma of n is nothing but n minus 1 factorial whenever n is a positive integer. Actually, while defining the gamma function here, this n need not be an integer. N can be any positive number, but when n is in positive integer, gamma of n can be written as n minus 1 factorial, and gamma of 1 is obviously equal to what? 0 factorial, so it is equal to 1. And this is the relation between beta and gamma function. Beta of mn is equal to gamma of m into gamma of n divided by gamma of m plus n. So this gives the relation between beta function and gamma function. Okay, so then by this property, how can I rewrite? Gamma of m is equal to m minus 1 factorial, gamma of n equal to n minus 1 factorial, and gamma of m plus n is equal to m plus n minus 1 factorial. Okay, next property is a slight modification of this gamma integral. Integral 0 to infinity, instead of this single variable x, suppose if I have lambda y, okay, e power minus lambda y into y power n minus 1 dy, it is equal to gamma of n by lambda power n. Okay, next one is gamma of n plus 1 is equal to n into gamma of n factorial. Another one is gamma of half is equal to root pi. Okay, for all positive integers this relation is true, but when you have fraction, gamma of half is equal to what? Root pi. So this is a very important property that we frequently use while doing problems. And integral 0 to infinity e power minus z power 1 by n dz equal to gamma of n plus 1. And see, beta integral is defined from 0 to 1, no? 0 to 1 x power m minus 1, 1 minus x power n minus 1. But we have defined one relation for beta and gamma function. Now this is another form for beta integral. Beta of mn is equal to integral 0 to infinity. Notice that in definition we have only integral 0 to 1. Here it is integral 0 to infinity y power n minus 1, 1 plus y power m plus n dy. Okay, well, this is another definition for beta integral which will be useful for doing integration problems. Okay, then another one important property of gamma integral is gamma of n into gamma of 1 minus n is equal to pi by sin n pi, and gamma of 1 plus n into gamma of 1 minus n equal to n pi by sin n pi. All these problems will be very useful for doing integration problems. Okay, then next one is integral 0 to pi by 2 sin power m theta cos power n theta equal to gamma of m plus 1 by 2 into gamma of n plus 1 by 2 into 2 times gamma of m plus n plus 2 by 2. See, already you have studied in reduction formula for 0 to pi by 2 sin power m theta cos power n theta. You have a reduction formula, but that reduction formula you have studied for only for m and n are positive integer, but this formula is applicable for any values of m and n. Okay, next one is duplication formula of gamma integral. Gamma of m into gamma of m plus 1 by 2 is equal to root pi by 2 power 2m minus 1 into gamma of 2m. This is also an important property. So you have to by heart all these 12 properties for doing integration problems. Okay, right, let's do few problems based on all these properties. First one is find the value of gamma of minus 1 by 2. Okay, see here we have minus 1 by 2, no? So for negative numbers we don't have any direct definition. So what I am going to do is I am going to make use of the property gamma of n into gamma of 1 minus n equal to pi by sin n pi. This result already I have stated, no. In this result you take n is equal to minus half. Then what happens here? Gamma of minus half into gamma of 1 minus minus half, no. So it will be 1 plus 1 by 2 equal to pi by sin n pi. But what is n here? Minus 1 by 2. So pi by sine of minus pi by 2. But sine of minus pi by 2 is what? Minus sine pi by 2. So it's equal to minus 1. So in this right side you have pi by minus 1 equal to simply what? Minus pi. What about left hand side? It is gamma of minus half. Here this is gamma of 3 by 2. Okay. So gamma of minus 1 by 2 is equal to minus pi by gamma of 3 by 2. For gamma of 3 by 2, what can you write? See, already I told you on a formula, no? That is gamma of n plus 1 is equal to, how can I write? N into gamma of n. Okay, regarding fractions, you know only the value for gamma of half. So this I can write it as n into gamma of n. This I can write it as 1 plus 1 by 2, no? So using that formula, gamma of 3 by 2, how can I write? Gamma of 3 by 2 is equal to gamma of 1 plus 1 by 2, isn't it? 1 plus 1 by 2, which you can write it as 1 by 2 into gamma of 1 by 2. Okay, that is what I have written here. But this gamma of 1 by 2 is root pi. So by simplifying, we get the result gamma of minus half equal to minus 2 root pi. Okay, then next problem. Show that gamma of 1 by 3 into gamma of 5 by 6 by gamma of 2 by 3 is equal to root pi into 2 power 1 by 3. See, this one 1 by 3 and here it is 5 by 6, no. So 5 by 6 is obtained by adding 1 by 2 with this 1 by 3, isn't it? So when you add 1 by 2 with some number, you can make use of duplication formula. What is its statement? Duplication formula, gamma of m into gamma of m plus half is equal to root pi by 2 power 2m minus 1 into gamma of 2m. So here m is equal to 1 by 3. Okay, so you substitute the value gamma of 1 by 3 into gamma of 1 by 3 plus 1 by 2 equal to root pi by 2 power 2 by 3 minus 1 into gamma of 2 by 3. So this will be what? 2 power minus 1 by 3 and bring it to the numerator. It will be 2 power 1 by 3 into root pi into gamma of 2 by 3. Now you bring this term to the left hand side. So what we have? Gamma of 1 by 3 into gamma of 5 by 6 by gamma of 2 by 3 is equal to 2 power 1 by 3 into root pi, which is the required result. So the only thing is you have to be thorough with all the 12 properties I have stated. Be thorough with them. Okay, for doing problems you can apply any one of the properties to derive the result, right? Okay, next problem. Evaluate integral 0 to infinity dx by 1 plus x power 4. Okay, right. So whenever you have integral 0 to infinity, you have two choices. The first one is you can make use of gamma integral, but for using gamma integral you should have the exponential term. But the exponential term is not there, no. When there is no exponential term, you can make use of the beta integral defined in another way. What is the definition? Beta of m1 equal to y power 1 minus n by y power 1 minus n by 1 plus y power m plus n, isn't it? That formula I am going to make use here. So for that, here I am having 1 plus x power 4, no. This is not the right form we should have. So what I am going to take is, I am going to take this x power 4 is equal to y. If you take x power 4 equal to y, what about dy? 4x cube into dx. Therefore dx equal to 1 by 4x cube into dy. Okay, instead of this x, you substitute y power 1 by 4. So dx is equal to 1 by 4 y power 3 by 4 into dy. Okay, substitute all these values in the integral. So you will be getting integral. Limits are same. When x varies from 0 to infinity, y also varies from 0 to infinity only. 0 to infinity. Instead of dx, I am substituting dy by 4 y power 3 by 4 into, instead of this 1 plus x power 4, I am writing 1 plus y. Now rearrange this term. So 1 by 4 integral 0 to infinity y power minus 3 by 4 into 1 by 1 plus y into dy. This is the definition, alternate definition for beta integral. You compare these two things. So from this we can identify m equal to n minus 1 is equal to minus 3 by 4, isn't it? So and here m plus n is equal to 1. So n equal to 1 by 4. If you substitute n value here, m equal to 3 by 4. So the value of this integral is equal to what? Beta of 3 by 4 comma 1 by 4. So the value of the integral equal to beta of 3 by 4 comma 1 by 4 into, already 1 by 4 is there in the problem. So that 1 by 4 you put it here. So 1 by 4 into, for this I am applying the formula beta of m1 equal to gamma of m into gamma of n by gamma of m plus n. So gamma of 3 by 4 into gamma of 1 by 4 by Gamma of 3 by 4 plus 1 by 4. So the denominator is simply gamma of 1. It's simply going to be 1 alone. So here in the numerator, this is gamma of 1 by 4. This gamma of 3 by 4 can be written as gamma of 1 minus 1 by 4. So this is of the form, again, gamma of n into gamma of 1 minus n. So it is equal to what? Pi by sine n pi. So pi by sine pi by 4 into 1 by 4. What is sine pi by 4? 1 by root 2. So pi by 1 by root 2 into 1 by 4. So the answer is pi root 2 by 4. Okay. The next problem, evaluate integral 0 to pi by 2 sin x power 8 by 3 into secant x power 1 by 2 into dx. Let the given integral to be I. Okay, so this is sin x power 8 by 3. Secant x, how can you write? Cos x power minus 1. That is 1 by cos x is only, secant x no. So secant x power plus 1 by 2 means it is nothing but cos x power minus 1 by 2 dx. Okay, so here this is equal to gamma of m plus 1 by 2 into gamma of n plus 1 by 2 by 2 times gamma of m plus n plus 2 by 2. Where m is the power of sin x and n is the power of cos x. So m equal to 8 by 3 and n is equal to minus 1 by 2. Simply you substitute the value, we will get the answer. So it's equal to gamma of 11 by 6, gamma of 1 by 4 into gamma of 2 times gamma of 25 by 12. So all these values are unknown values, so you can leave this problem here. Okay, right. Next one. Show that integral 0 to pi by 2 tan theta power n d theta is equal to 1 by 2 pi into secant n pi by 2. Okay, now tan power n. Tan theta is equal to what? Sin theta by cos theta. So this is sin theta power n into cos theta power minus n d theta. So what's the formula for this one? Gamma of n plus 1 by 2 into gamma of minus n plus 1 by 2 by gamma of n minus n plus 2 by 2. Okay, so gamma of n plus 2, this I am rewriting it as 1 minus n plus 1 by 2. Okay, because for applying the value I am rewriting it. In the denominator it is simply 2 into gamma of 1, so it is going to be 1 alone. Now for the numerator it is like gamma of n into gamma of 1 minus n, no? So it's equal to pi by sin n pi. What is the value of n here? N plus 1 by 2. So pi by sin of n plus 1 by 2 into pi. Now you multiply this pi inside, so you will be getting pi by sin pi by 2 plus n pi by 2. So this is like sin of 90 plus theta, isn't it? This is 90, this is theta. What is sin of 90 plus theta? It's equal to simply cos theta. So instead of this, I am writing cos of n pi by 2. So cos of n pi by 2, if you bring it to the numerator, it will be what? Secant n pi by 2. So the answer is 1 by 2 pi secant n pi by 2. Okay, then two more results let me explain you here. One is product of gamma functions. Gamma of 1 by n, gamma of 2 by n, etc. up to gamma of n minus 1 by n. See, all the denominators should be equal to n and the numerator starts from 1 and ends at n minus 1. In this case, the product of these n minus 1 terms is equal to 2 pi power n minus 1 by 2 by root n. Okay, then another formula, integral 0 to infinity e power minus ax cos bx into x power m minus 1 dx is equal to gamma of m by r power m cos m theta. Suppose instead of cos, if you have sin, it's equal to gamma of m by r power m into sin m theta. Here theta is tan inverse of b by a and r is square root of a square plus b square. A is in here in the exponential term, b is in the sin or cos term you are having, no, that is called b. Okay, so we'll do problems on this also. See, evaluate gamma of 1 by 9, 2 by 9, etc. up to 8 by 9. See, 1, 2, 3, etc. up to 8 and all denominators are equal to 9, no? So it is equal to 2 pi power 9 minus 1 by 2 by 9 power 1 by 2 by using that formula I have stated in the previous page. Okay, so it's equal to 2 pi power 4 by 3. So simply 16 by 3 pi power 4. Next, evaluate gamma of 0.1, 0.2, etc. gamma of 0.9. So let me rewrite this as gamma of 1 by 10, 2 by 10, gamma of etc. gamma of 9 by 10. So numerator from 1 to etc. up to 9, all denominators are equal to 10. So I can make use of that formula. So 2 pi power 10 minus 1 by 2 by 10 power half. So this is 2 pi power 9 by 2 by root 10. Next, evaluate integral 0 to infinity x e power minus ax into cos bx dx. Now compare this with the formula that I have given already. So this is the formula gamma of m by r power m into cos m theta. If you compare x power, here x power 1 is there, no? So m minus 1 equal to 1. That means m is equal to what? 2. Okay, so m minus 1 equal to 1. So m equal to 2 and a is equal to a and b equal to b. So r equal to root of a square plus b square and theta equal to tan inverse of b by a. All these things are there in the formula. Now let me substitute I equal to gamma of m instead of m you have to put 2 by r power m, so r power 2 into cos 2 theta, right? Now this is in terms of cos 2 theta, but I know what is tan theta. What is tan theta here? Here tan theta is equal to b by a, isn't it? So tan theta I know, but here cos 2 theta is there. We know in the formula, no, cos 2 theta is equal to 1 minus tan square theta by 1 plus tan square theta. In that one, instead of tan theta, you apply b by a. Okay, here this side, instead of r, I can substitute a square plus b square. Okay, gamma of 2 is equal to 1. So simply 1 by a square plus b square into 1 minus tan square theta by 1 plus tan square theta equal to 1 by a square plus b square into 1 minus b square by a square by 1 plus b square by a square. So after simplification, what I am getting, a square minus b square by a square plus b square the whole square. Okay, that's all. Thank you.